Ladies and gentlemen, please welcome to the stage Bret Hartman, Vice President, Chief Technology Officer, the Security Business Group, Cisco.
All right. Hey, everybody. Good to be here. This hopefully is going to be a fun session. I'm going to do my best. It's been a long week here. I just came from the main stage, the technology keynote that Liz Santoni ran and gave sort of high level. I don't know if anybody caught that. This one is, I am going to attempt to dig a little bit into the weeds very intentionally. So if you saw that, it'll sort of pick up where that left off. I'm going to switch this display so I can see it. Okay. So I'm Bret Hartman. I'm the Chief Technology Officer for the security group at Cisco. So my job is all about trying to figure out where the world is going around security, which is, has got its challenges. As it says, it's a massively dynamic threat landscape. Security is always this notion of an arms race, right? I mean, no matter what we do, no matter what awesome technology that we have, and we have a lot, and as we'll talk about, but there's always the next thing because the attacker evades it, then we update, and it takes a continued massive investment. And, you know, that's what we'll talk about a little bit. And this dynamic threat landscape is caused by some basic things that I'm sure you're all aware of. The growing attack surface. So when we think about attack surface, it's really about connectivity of machines, so things like Internet of Things, the cloud. I mean, all these, just the natural trend in the entire world around connectivity means that it's easier for an attacker to find a way in, right? Threat actors, we all recognize the expansion on threat actors. During the previous one, I was just talking a little bit about that anecdote around what we call Olympic Destroyer, malware based attack on the Olympic Games in South Korea back last month, which TELUS was involved in analyzing as an example. Attack sophistication continues to grow, ransomware very rampant, and it's really part of this broader topic of multi-vector threats. More and more we see that it's not just one notion, one piece of malware, but it's part of a much broader campaign. And I'll share a couple statistics around what we're seeing out there. So this is a statistic from the Cisco annual cybersecurity report that just got released. It's something that for the security practitioners in the room, I definitely recommend you check it out. It's totally free. If you just Google Cisco security report, cybersecurity report, you'll find it. And basically what it does is it shares what we've seen across the entire world, across different verticals and customers, what we're seeing out there. So for practitioners, always good to know what's out there. It leverages Talos. We'll talk a little bit about that, but our threat research team. So here's one statistic. Just over the course of the last year, we saw a 10 times increase in the number of threats that we have seen. Part of that is Cisco's footprint continues to grow, but part of it is this natural expansion. So that certainly gives you pause in terms of thinking about the broad set of threats out there. Second big trend that all organizations face is just complexity, the fact that there's lots and lots and lots of security vendors out there and lots of products. Another statistic from the annual cybersecurity report is this one, actually a lot of statistics. And what it shows is that as organizations use more and more products, and there's lots that do, 20 plus security vendors, it gets harder, right? Orchestration is pretty obvious correlation. Orchestration challenges continue to grow as you have the number of products grow, and that happens across lots of verticals. Now, certainly Cisco, we certainly believe we have a role in the security group to help fix this problem. Not that any one vendor, Cisco or anybody else, is just going to solve it and it's going to be one vendor and you're done. But certainly we have a big role in terms of investing and growing the portfolio and making sure it works together and addressing a larger and larger part of cybersecurity needs. And it's a really big scope, and you're going to see it hopefully very concretely when I share more details on this. So certainly we have a big role there. And we work, of course, with lots of partners too. The third trend across the world is this just inherent challenge in terms of the lack of cyber expertise that's out there. Nobody can hire enough folks. It's an awesome career to get into because you're pretty much 0% unemployment in cybersecurity. Really hard for employers to retain folks because there's so many opportunities. The result is we're seeing organizations across the world look at outsourcing. They just can't hire the people, so they look at other ways to address security, whether it's through consulting or monitoring, managed services, incident response. Year after year, we continue to see this trend grow. I have no doubt that as the years go on, it's just going to be more and more people that are going to buy security through a managed security service provider, and less are buying it directly, assuming the MSSP is able to keep up with that. So this is clearly a trend. And of course, Cisco provides all these services as well. We do it a lot through partners. Some of you may be in the room. We do a lot through partners locally. And then we help, we do some directly too. Come on. There we go. So there's a basic question here in terms of how can we change the security equation with all these challenges as we've thought over the last several years. What do we do to invest and grow and be able to make progress towards these equations? And what we've done over the last few years is kind of a balance between these two things, which is we've got a big portfolio, lots of products, and it's important that each of the individual products solve a problem all by itself. A customer can buy it and use it and deploy it, and it works well, and it's highly competitive, and it's Gartner Magic Quadrant and all that good stuff. But it's also every bit as important to have an integrated architecture, that the products actually work together. And again, you're going to see a lot of this in the demo. And so it's basically balancing these two things, because you can't say everybody's got to buy all the products, right? That doesn't really work. You have to solve specific problems, like I got a problem with advanced malware or with email or with a firewall or so forth that I need to address. But certainly, our strength, and I really do believe we've got awesome strength here, is in terms of being able to have the products work together, and that's primarily done through sharing of threat intel. Threat intel, events, context, all done through the cloud, and that absolutely leads directly to Talos. If you have a chance to catch any of the Talos presentations this week, totally highly recommend it. They're all completely frightening. They're like the worst gloom and doom scenarios, and they go into lots of concrete detail. There was one, as I mentioned, the Olympic destroyer is an example. I alluded to it in the keynote before, but this was an attack that was directly to disrupt the games. Fortunately, it was caught early on, but the malware analysis that Talos did is a really interesting read. Talos puts out these fantastic blogs these days, like couple times a week at least, and really it's all about being able to share this information. So massive scope, telemetry from millions of sensors, and what this 300-person research team does is, based on that, do threat hunting every day. Look for the latest ransomware, new 0 days, the threat du jour, and then takes that and does a bunch of work. Does analytics, machine learning, updates policies, updates rules, and then pushes them back down into the product set, so the products hopefully stay current with respect to the latest threats without customers actually having to do anything. The whole point is you should deploy these products, and you get the feeds from Talos that keep it current and help you out in that arms race. And you can see the statistics on scale. It's pretty cool. So overall approach and the overall goal with respect to security is basically addressing this seemingly simple question: do you have an effective security posture? Which of course in practice is really, really difficult. And in practice, what it really means is a battle against time. It's how much time does it take between the time an attacker starts, a threat shows up at your doorstep, to when you detect it and remediate it. And this is a battle because it's really complicated. You may not be able to see the threat in the first place, and there's lots of information, I'm sure you've read it, where sometimes organizations can take months or sometimes years in this time to detect, time to respond. And so the goal of all organizations is compressing that. The faster you can detect it and respond, the less likely is an attacker is going to go in and do damage. So that is all the technology of all the security vendors in the world is all about kind of getting to this, narrowing the window. We have some pretty awesome statistics on this. In our case, across the entire world, Our time to detect, our average is 4 hours. And what that means is that from the time that some threat, the first time it's encountered anywhere on the planet, right, this includes all the new 0 days, to the time that it's detected and then blocked across the planet, averages 4 hours, which is by far as I know, the best in the industry. You have to do massive scale and have massive visibility. Okay, so now I'm going to shift gears and do something that's very dangerous for a CTO. I'm going to attempt to do a demo. And we'll see how it goes. I think, so fortunately, no, there's nothing too clever. This is a recorded demo, but there's actually quite a bit of content here. But what you're going to see, hopefully, is the concrete really demonstration of almost the entire portfolio, and do it in 34 minutes and 34 seconds. So we'll see how this goes. I'm optimistic. So day in the life of malware. Basic concept here. Malware comes in from some awful place outside, PDF file, some kind of executable. Obviously, it travels through the internet and attempts to get onto your machine somewhere, right? So what we're going to do is talk about all the different products and how they sort of work together in different parts of this to be able to detect and stop this threat, right back to that time to detect thing we're talking about. So first step is oftentimes organizations have nothing deployed, and they want to understand how bad is it. So we actually have a free service that we offer. This is something that you can talk to your friendly Cisco account management team, and we'll come in and instrument your system, and within, basically it analyzes the system for a couple weeks, and you can get some really interesting data out of it. And now hopefully I will show you what you get. So it's called the Security Online Visibility Assessment, and this is the kind of console you see from this. And what you see across the top is some stats on the amount of the monitoring with respect to the overall network, the size of it, the amount of traffic that we're looking at. You can see the categories that we're looking at in terms of things like DNS risk and telnet and the like. Another part of the analysis is looking at traffic to high-risk countries, I should say. And for some reason, Canada is considered high risk in this demo. I'm not sure why. But the point is that you can customize that. So based on where you happen to be running your favorite countries that you're worried about, you can click and configure that. But that's useful data to know. So what we can also do is be able to look specifically as a case in point of DNS risk. This is actually a pretty interesting topic, which is if there's malware, oftentimes they will use an unauthorized DNS server that you don't want to go to, because often malware uses that DNS server to find the IP address to serve up malware. So part of this report is looking at DNS servers that you probably don't want to be used, and the hosts associated with who is using that. So back to, which is a very, very strong indication that there's something really bad happening on these hosts, if that's the case. Okay, so then what you can do based on all this analysis is generate a nice report. And the report has all kinds of options, several of which I mentioned. You can point and click and decide which ones are relevant for your organization. And you generate a lovely report that you can give to your manager and say, look, these are real issues. You might want to think about what we're doing here. And you can see it's very nicely printed out. Even managers can read this report. Sorry, I hope there aren't any in the room. I'm sure it's all technical. But basically, it sort of says these are the problems. And again, this is something that we'll do free of charge. Go in, it analyzes, and you can check it out. So that's the first step in our journey, is just, do you have a problem? Well, big surprise, the vast majority of the time, most organizations do. Okay, so typically in this, as we think about kind of multiple products, where to go, Umbrella, which is our DNS, OpenDNS, DNS-based security offering, oftentimes is this first layer. Pretty basic concept here, which is DNS resolution is what everybody does when you access the internet hundreds or thousands of times a day, right? It's built into the way the internet works. And it turns out that if you do a DNS check to determine whether that user is going to a sketchy domain or a sketchy IP address, that's really useful. And you can do it right at the beginning before anything they even get to that evil site. So that's the whole purpose of Umbrella, is to be able to do that. And the nice thing about DNS is you don't necessarily have to install software. There's no hardware to install. And you have to use a DNS resolver regardless. Everybody has to use it. So by using Umbrella, you get very fast DNS resolution and you get threat protection. And by the way, it works not only for laptops and desktops, but it also works for things like webcams and thermostats and all the other smart devices, because they also use DNS resolution. And IoT, you know all the stories about various kinds of devices and compromises there. All right, so let's take a quick look at what Umbrella looks like. So high-level view of the Umbrella console, the security overview, and you can see some stats in terms of the DNS requests and what's blocked out of those requests, as well as, if we scroll down, some stats on what's blocked. And you can see these are pretty questionable domain names, Y4BXL, so forth. That's probably not a legitimate one. There were a couple in there that I thought were pretty entertaining. But anyway, what we also do is we can monitor exactly what parts of the internal network are under control or monitored, as well as roaming computers. So one of the important things in terms of the Umbrella deployment is we have ways to make sure that your device is monitored and controlled for DNS resolution, not only when it's on the corporate network where you can control your DNS resolver, but also when you're roaming, right? When you're sitting at Starbucks, right? And to be able to do it there. Right. So then on the monitoring side of Umbrella, you can get lots of statistics about the security activity. We see things like what happened in the last 24 hours and statistics about particular blocked attacks, or what happened over the last 30 days and the like. So you can get lots of information with respect to those activities. You can also do drill down to determine specific kinds of blocking that occurred, and you can see the long list here and sort it by things like based on a DNS or URL or IP-based request. You can also even drill down further, and this is where you can see some really interesting stuff. So for example, here is a case in point where, there it goes, this is blocked, for example, by AMP. So here's a linkage that I talked about in terms of the architecture between the DNS resolution and advanced malware protection that we're talking about. So you can see exactly the value that the Umbrella portion has with the rest of the portfolio here. We can also get statistics about this domain. You can see what happened over the last 30 days. You can also, there it goes, you can also see global traffic. So the percent of global traffic, this is relevant because when you look at a domain, you can determine, is this a targeted attack to you? Is most of this domain aimed at you, or is this part of a much broader worldwide attack, right? So because Cisco has the visibility, and given that this particular attack is 0.5% of the world traffic, odds are there's a bigger thing going on. It's not just targeted to you. So that's useful intelligence. Okay, and we can also go deeper into that domain and to investigate. You can look at the pattern of the DNS queries. You see a spike right there. That's a bad sign. That means there's probably a campaign going on at that point in terms of this questionable domain. And it also links, again, back to AMP and the malware, back to the malware samples associated with this domain. So, incredibly useful tool for an analyst. So the other part in Umbrella is setting of policies, right? Because there's a lot of different policies you can define, and so there's a whole interface to be able to control those policies. So you see here, these are the kinds of things you can select. Are you going to check with respect to websites offering up malware content, new domains, which are usually questionable when a new domain appears? That's usually itself a bad sign. You can get the idea, phishing attacks and so forth. So what we can also do is have advanced settings. For example, in some cases you want to do proxy, SSL, TLS decryption and proxying to provide deeper inspections, so supporting that as well as things like logging. So that's Umbrella. So now what we've seen, first step with respect to this DNS resolution and what we do there. Okay, so next on our tour is the notion of threat protection, classic firewall stuff, right? NG firewall, and that's our firepower offering, that next-gen firewall that many of you are familiar with. And this is a brand new interface, the Firepower Device Manager. This is targeted to kind of low and mid-end, so the 2100 and low to mid-end ASA, and it's a redefined on-box management to be very clean, point and click, simple. I mean, because there's lots of feedback that the simpler we can make it, the better. And so you can see everything is green here, which indicates that the interfaces that the firewall's hooked up to are okay. You can see all the information with respect to what's hooked up. You can be able to control and configure the interfaces. So we're gonna drill down a little bit into this in terms of the variety of security policies that are associated with this Firepower device in this case. So you can see across the top, there's a number of these firewalls, right? You can see SSL decryption, identity, intelligence, NATing, access control. So SSL decryption, classic case, we want to terminate traffic to be able to inspect it. And you can turn on SSL decryption just by toggling the switch. So very simple configuration. A rule is automatically set up to, if you want to, you can shut off inspection for very sensitive data, to deal with privacy issues and the like. So you can configure when you want to actually inspect encrypted traffic and when you don't. So next on this is security intelligence. We talked about Talos, all the feeds. This is the example of how you can configure those intelligence feeds from Talos. This is an example of bots, for example, right? The intelligence we get there, so you can, again, configure exactly which sorts of feeds you want Firepower to be able to detect and enforce. We move on to access control. Just like every firewall on the planet, you got the usual, ports and zones and networks in terms of access control. Here we're looking specifically around intrusion policies, and there's always debates about whether you're putting intrusion detection in blocking mode or not. This gives some options in terms of trade-offs of, as you see, connectivity over security or both. So you can determine based on your operational requirements the trade-offs between security and connectivity. We're going to drill down just a little bit more. So file policy. So file policy, again, back to malware. This has the ability, again, for the firewall to be very relevant, to be able to detect and block malware that's in associated content. So PDF files and the like and content in that environment. And then finally, on the intrusion side, if you really want to get fine-grained, you can go into the very specific rules and configure them one at a time and determine, for example, whether you want to drop traffic or just alert it and let it pass through. So again, that's highly configurable in this case. So you can see, new interface. There's been a lot of investment, continued investment in terms of simplifying the management of the whole, next-gen firewall and suite to be able to make it easier for both security and network administrators. Okay, so now we move on to another issue, very common one, which is what do you do about encrypted traffic? Well, of course, you just saw in this example in the for Firepower that you can potentially put, leverage the firewall as a proxy to inspect traffic. But in a bunch of cases, in more and more cases these days, that's actually not possible, especially as we look to the new version of TLS 1.3 that has forward secrecy. It's not generally practical to put a proxy to inspect traffic. There are also plenty of other examples where you may not be able to inspect traffic to decrypt it for privacy purposes, right? The traffic is tunneled specifically to protect individual privacy. It may be against the law to inspect the traffic. And it also tends to break more and more cloud applications, right? That you have certificate pinning, so you from the application to the cloud service, it's a tight coupling based on TLS, and you cannot put a proxy. If you put one in place, it breaks the app, and that continues to grow. More and more of those apps. So the basic question is, so what do you do if you can't decrypt the traffic? How do you deal with threats? And we've done a lot of work in this area. Of what do you do around securing encrypted traffic, and there's a whole space, as far as I know we're still the only vendor to address this, is around encrypted traffic analytics. So I'll show you what that looks like. Okay, so here we see, this is the dashboard really around StealthWatch and the broader kinds of information we get around network metadata. But the interesting thing is there's actually some new features in the lower left here, the cognitive threat analytics, which is looking specifically at threats on encrypted traffic. And what you can see on this Dusty Hilton, which hopefully you can see in the back. So this is a case. Dusty Hilton with a risk score of 10 has ransomware on it, and you see that little label on the right of it that says encrypted. So what's happened is this is an encrypted traffic stream, and normally you would never see this piece of malware because it's encrypted, and it would be extremely difficult to detect this ransomware. So by doing additional analytics on metadata, the techniques behind this are kind of a whole talk in and of itself, but in a nutshell, in addition to things like NetFlow and DNS-based telemetry, as we talked about before, you can look at TLS headers, you can look at timing information, packet timing information, byte distribution, some HTTP headers. So anyway, by combining multiple sources of metadata and using machine learning, you basically build up a malware behavior, and with very high degrees of accuracy, we can identify threats in encrypted traffic without having to look at the payload at all. It's actually, again, pretty cool. So what we're going to do in this case is drill down a little bit into that host. So this is the host associated with Dusty Hilton. And what we see in the middle here is that this particular host that certainly our tools are with a high degree of confidence believe is contaminated by this malware we just detected. It looks a little scary because the host is widely connected. You see it's connected to the data center, it's worldwide connection, which means if this is a contaminated host, it's got a really good chance it's going to propagate across the world. So that's bad. We'd like to stop that. And let's see if we can click. There we go. Okay, so let's drill down a little bit more with respect to this. Again, back to the lower left side of this. And what you see is some more background in terms of why StealthWatch and Cognitive believes, with this high degree of confidence, believes that this is actually malware, even though it's encrypted. Uses a Tor relay, which is pretty questionable in and of itself, related to the host. And then basically it's saying this is, everything it sees looks like it's WannaCry as a case in point. Okay, so then we can also get additional information that's quite relevant with respect to this host. But more interestingly here, see the quarantine button? It kind of clicked fast. But this quarantine calls off to ICE, the Identity Service Engine, the access policy part of our portfolio. And with that click, it actually just cut off that user and that host from the network. Typically, in most organizations, that's kind of a complicated manual workflow that just happened. And the idea is to replace it by that click so that if you see something is evil like that, you can shut them off right away to make sure they're not doing further damage, and then work to clean up that host. All right, so that's sort of a, again, quick nutshell with respect to what we're doing around advanced threat. Moving on to the next piece is AMP. You've seen a couple little pieces of it, but going to look some specifically around advanced malware protection. So this, in this case, is primarily AMP for endpoints. So what is running on your typical laptop or desktop or the like. So let's explore that for a minute and what that console looks like. Before we get to the console, here's your classic use case that we all talk about these days. This piece of email that somebody's got. They've got an attachment. It's a little, it at least seems pretty obvious. I wouldn't click on that, but in this demo, they click on it. So what happens? Well, surprise, it's WannaCry. It's a piece of ransomware. And again, I'm sure you've seen some demos like this, right? So they click on the link. What happens? Your files get encrypted. It gives you the warning that if you pay bitcoins, then you'll get the decryption key to get your data back. It turns out in the case of WannaCry in particular, if you do attempt to pay with Bitcoin, it actually doesn't work. In the case of that, you actually cannot restore your data. It just damaged it in the first place. So not good. Okay, now we're going to switch over to AMP to look at, in the context of that particular ransomware, what do you see in AMP? And so main dashboard kind of talks about the status, the overall status, and we're going to drill down again a little bit. and look specifically. We're going to go, there you go, you can see, going to go to the inbox. That's like kind of the to-do list for the administrator, and we're going to take a look to see just what's going on with this particular piece of malware. And so in particular, what you see down there at the bottom, there is an attack is in progress, and it turns out to be that piece of WannaCry, that WannaCry ransomware. We see 300 incidents that have gone on in the last 9 hours. Bad sign. The interface gives you lots of information related to this particular attack, the operating system, the host, and so forth. And so we're going to drill in a little further to see what kind of intelligence we can get. Now, this notion of device trajectory has been kind of one of the strong points of AMP for Endpoints for a long time, and it really shows how this piece of malware gets convicted by AMP. It's looking at the trajectory of the executable and what it's touching in the file system and on that host. So you get lots of information with respect to that propagation. Now, there's a new feature that's appearing, which is AMP Visibility, which is pretty cool, that gives you more visibility of that piece of malware, not just on that host, but across the environment. So what we see here in the middle is that piece of malware and all the associated entities and files that malware has touched. And so, in a second, we're going to drill in even further. You can see, first of all, the kinds of intelligence sources that help convict that malware, the AMP intel from Talos. Also, external sources like VirusTotal can be used. And then we're going to drill in even a little more and look specifically at some of the background behind that piece of malware. So there we go, the piece of malware. You can see on the left-hand side gives you some information about when in your environment we first saw it and the last time we saw it. So it gives you sort of some windows in terms of where, is it still there? Is it gone? That sort of thing. Along the bottom is more information, the hash that you can use and export to be able to share it with investigators and others. And along the bottom is more information to be able to do investigations. So first, we've got judgments, right? So what sources of threat intel, believe this is questionable. We got verdicts in terms of whether we saw it was malicious. The sightings, what we have seen with respect to that malware in the environment. And then finally, the indicators, which is why do we think it's malware? Things like, okay, an AV service, sometimes, that can be useful, but oftentimes you get false positives there, especially, these days, and oftentimes AVs miss it a lot these days. So this is an additional level of inspection. You can see a whole bunch of additional kinds of metadata that's used to back it up. So that gives you an idea of AMP and sort of the whole point is, extending the behavioral analytics beyond what you typically see, certainly in your classic AV. All right, so last step in our tour is email. So number one threat vector, as it says, we all recognize that most of those attacks, like you saw in the example, come in through those links. So email. Switch the window, and here's the email console, and you get some high-level stats with respect to the messages that are monitored. And I mean, right away, you can see a massive number of the overall messages are actually malicious in some way, whether that's related to spam. Big surprise, there's a whole lot of spam in typical environments, different reputation policies, DMARC, and the like. For this discussion, we are going to focus on this malware use case. Of course, the email product is far broader than just malware, but for this use case, it's all about protecting against malware. So you see the threat detection summary there, the different stats with respect to the email security product, what it's seen, what it's blocked. You get stats in terms of the rates over the last few months. What we're going to do for this demonstration, again, is narrow in on malware. So what's happening here is we're unchecking the other functionality in email, like spam and stuff, and just focusing on malware to be able to see what the tool does and what kind of insights we can get out of malware. And we can, again, see the stats of malware detection in the environment over the last few months. Now, then we're going to look specifically around AMP, the Advanced Malware Protection part of this demo. and look down. Now, the first thing you see is these are 7 files. A pretty small number of files are uploaded for analysis. Those are basically 0 days. So very small, something that nobody has seen before. We'll get back to that in a minute. But overall, that gives you the bigger picture of malware we see in the organization. We see the hashes on the files. We see the file types. So they're zip and DOS exec. So pretty common Windows files, file types. Now we're going to go specifically into the AMP reputation that gives you the information specifically in terms of what did advanced malware protection do, particularly for these more sophisticated attacks. Again, you see the specs with respect to the files incoming, as well as the file types, which match what we just saw. Now the file analysis. So this is where Threat Grid, the sandboxing part of the technology, is relevant, and those are the 7 samples I talked about. So you can set it up to automatically provide those samples to Threat Grid as part of the broader AMP offering. So in the pretty unusual case that nobody has ever seen these and AMP doesn't know what to do with it, you can send those files automatically, this is entirely automatically, and get the results back, and then you can see the disposition with respect to those. Okay, so that is the end of the tour part. But what you saw here is that you actually saw, it's remarkable, it's even possible, but in about half an hour, I demonstrated most of the portfolio around security that we have. I didn't touch on ICE, the Identity Service Engine, which is a whole other topic in and of itself. I didn't talk about CloudLock, the Cloud Access Security Broker. I think I covered most other components, at least to some extent, in terms of the portfolio. So, hopefully you got a decent idea in terms of kind of the scope. And again, say it one more time, it's about architecture. It's about these things working together. Each of the things I talked about, of course, can be deployed by itself, but certainly there's a whole lot of value in terms of the kinds of threat intel and context they share. And in fact, that's the purpose of this slide, is all the back-end engineering we've done for this cross-domain analytics. Each of those products that you saw has its own analytics stack, its own machine learning. Like for Umbrella, for example, a lot of analytics around DNS and IP addresses and just constant analytics to determine what's a suspicious domain and IP address, for example. Same thing around things like Threat Grid that I mentioned around sandboxing and the like. But then the point is to make it cross-domain, to be able to take from all those sensors that you see in the bottom, all that kind of infrastructure, to be able to share it across multiple big data repositories. So the point here, if it's not clear already, it is about architecture. I am completely convinced that really the only way to address the kinds of risks that organizations face today, you need an architecture. You need, either, the more that Cisco can help in that architecture, great. But if not, you still need an architecture, right? You still, to be able to deal with the problems out there, somebody has got to integrate and connect these products together. And we're working really, really hard to have a strong, compelling set of technologies that actually do work together. Network side, you saw that around next-gen firewall and firepower. You didn't see ICE explicitly. You saw a little call out to ICE, but the whole network, wired, wireless, access control, authorization policies. Saw a little bit about Stealth Watch. Tetration is another related topic. There's plenty of other demos around tetration at this event. AMP, you saw lots on that. AnyConnect, the VPN-based approach, of course, very important, continues to be important. Email, you saw Umbrella. CloudLock in terms of Cloud Access Security Broker. And also we have StealthWatch analytics for the cloud to be able to do the same kinds of metadata analysis for network traffic that I talked about on-prem. StealthWatch Cloud does for the cloud, particularly for AWS. So you can look at workloads and behavioral workloads in the cloud and tie what happens in the cloud locally. So, again, Talos sits above it. The whole idea is to collect all these feeds, Talos do the analysis and push down the results, as you saw in that demo. So yeah, basic principles here. What we're focused on. Hopefully, have a really awesome portfolio. We're proud of it. Continues to grow. It's actually the world's largest enterprise security portfolio in the world now, and it keeps growing. Second, integrated architecture. Hugely important to do the engineering to tie it together, and then tie it to a great extent with intelligence, the ability to tie different intelligence feeds, different threat feeds across the environment. All right, so I am done. It looks like we got 5 minutes left. I'm happy to entertain a couple quick questions if anybody has it, and I'm hoping there may be an SC or two in the audience to rescue me if it's stumped the CTO time, so we'll see how I do, but yeah, please. Yeah, great question. So the question is, when we think about the definition of endpoint, what about servers, right? Is it just user devices, or does it count on the server, like databases, app servers, right? So we include both. Now, most environments generally today tend to focus on user devices as the primary exposure, but we're seeing massive shifts, and some of the recent breaches, not Petya as a case in point, have been server-side attacks where malware has got into the data center and rapidly propagated. So yes, we do include in that definition servers, and we see more and more deployments where we're expanding that footprint on the server side, yeah. And to me, and my view going forward, that's going to be over time just like table stakes, that everybody should be ultimately, I think, deploying malware on the anti-malware approaches on the server side, in my opinion. But it's still early. I think most customers probably don't yet, right? And it also depends, too, on the environments. If you can lock down and configure servers and have a lot of configuration management, maybe you could argue you don't need it because it's not possible to change the code. But in a lot of environments, virtualized environments, new workloads are showing up all the time, and you have no clue whether they're malware. Any other questions? Yeah, in the back.
One of the things you mentioned was around orchestration. When is it going to be that we're going to see these, all of these key capabilities sort of be melded together so that actually you've got one pane of glass to actually put your eyes on?
That's a good CTO question. So that's it. So the question around orchestration, yeah, big. So, our focus around the broad topic of sort of security operations generally, you saw hints of it here, but there's a lot more we could do, to your point, around security orchestration. And the whole big topic of security orchestration automation is a big deal these days. Now, we partner with kind of your classic SIEM vendors. We do a lot of work with Splunk, we do a lot of work with IBM, do Radar as cases in point. But that's an active area of investigation in terms of where we go beyond that to tie basically more and more automated response. You saw the example of the click to be able to connect from convicting a piece of malware to be, in StealthWatch to be able to shut it down in ICE, which is a very simple example. And so we're continuing to expand the automated response. So the good news is now there's so much of our infrastructure on the security side, as well as DNA and the rest of the network stack, that has the APIs, so they're orchestratable, right? We can tell them what to do, and typically for incident response, it tends to be a network type control, right? You want to do reroute, block, quarantine, right? You want to tell some network device to change the path of traffic due to some threat. So the good news is our products are capable of it. The APIs are there. The hard part is you got to have really, really accurate intelligence, because if you have a false positive or if you make a mistake and you do that orchestration and you're wrong, organizations aren't very happy, right? So working to ensure that you have very high quality, you have like a human in the loop to make sure they're okay with that. Those are the things we're working on now. Stay tuned. It's all inside of engineering, but definitely a big, big topic for us. Yes, more and more orchestration automation. Okay, we got like 1 minute left. Maybe one last question, if anybody's got it. Or if you're tired, that's okay too.
Thank you. So in the whole architecture, we've seen, at the end goal is to protect the endpoint, right? So,
well, one of the goals, right? But it's, certainly in this demo, you're right. There's a lot of focus on endpoint, but it's not just about endpoint by any means. Yeah.
So why not to have something on the endpoint itself? I mean, just your thoughts around it. I'm not saying that we are going to have that. Just to have something on the endpoint which will protect the endpoint rather than having 10 other things sitting outside the endpoint.
Yeah.
Right? Especially considering the complexities around encrypted traffic and other stuff.
Very, very insightful question. You're absolutely right. So first of all, to be clear, we do, the AMP for endpoints, the thing I demonstrated, is in fact an agent that runs on the endpoint. So absolutely the case. The issue is, and it was implied in that diagram, but stopping malware when it's about to detonate on the endpoint is like last resort, right? You're absolutely right, you need that, but it's so much better if you can stop it way earlier, before the malware even comes in, and detect it earlier. You're avoiding it propagating to maybe 10,000 machines that then it's just sitting there waiting to go off. So that's the whole really argument of these steps, is that if I can detect it, the earlier the better. But I can't rely on that entirely too, because sometimes something does slip in, to your point, and you need the endpoint visibility. That's really a great example of this architecture argument, that you need both, right? If I can do all the triage and get 95% of the garbage out, that allows me to have much more focus, and if something finally gets in, to be able to see it and deal with it. And the damage is likely to be far lower, right, because of that. That's the whole idea. But you're absolutely right. Endpoint presence is crucial, and we continue to grow. I mean, we have strong offerings, and you may know, for example, as far as I know, we have the only endpoint agent that's running in Apple iOS, for example, for the security connector, the work we do for iPads and iPhones, right? So we have a partnership there. So endpoint agents presence, big deal, very important. All right, I think we are out of time. Thank you very much. Hopefully that was helpful, and I'm glad I made it through the demo, so thank you.